Hi, I will briefly introduce our tool RefactorHub, a commit annotator for refactoring. Refactoring is now a common technique to improve the internal structure of software. To understand how real developers conduct refactorings and how they are efficient, many empirical studies about refactoring have been conducted. When conducting empirical studies, we need to collect refactoring data, a set of refactoring instances that were performed in practice. But how can we collect such refactoring data? A typical approach is to use refactoring detection tools. Several tools such as Refactoring Miner or refdiff can detect refactoring instances accurately attached with their rich details. However, the refactoring types supported by these tools are limited, which leads to low type coverage. In contrast, more lightweight approaches such as keyword search of commit log messages may be able to find more variety of refactoring-related commits, but such an approach is inaccurate and it doesn't provide the details of the detected refactorings. To have many accurate refactoring instances with rich details, we need a manual validation. We propose RefactorHub, which is a new tool to support the manual annotation of refactorings in a commit. The input of RefactorHub is a commit, which may be refactoring. During the annotation process, the user sees the code diff and selects code elements related to the target refactoring. We call them refactoring parameters. Here, for annotating the extract method refactoring applied in the commit, the extracted println statements are selected as extracted code. Newly defined method print details is selected as extracted method, and the added method invocation is selected as invocation. Finally, the tool outputs the set of these parameters as an accurate refactoring instance information. RefactorHub mainly 4 panes. The target refactoring information, such as commit log message, the parameters of the target refactoring in the before and after versions, the list of modified files in the commit, and the code difference. This is how extract method refactoring is annotated in RefactorHub. To specify the parameters, the user is first understanding the diff. After that, the user is specifying which code fragment was extracted and noting its location as the parameter extracted code. As a result, the parameter target method is automatically derived as a parent method of the extracted code parameter. Next, the user specifies the newly added method invocation as the new versions of the code. RefactorHub automatically highlights method invocations as the candidates to be selected. The user is selecting one of them, and the target method parameter is also automatically derived. Finally, all the parameters are filled out, and the result is exported as a JSON file. In the proceedings, you can see the result of our preliminary study on how RefactorHub was effective in selecting parameters. The source code of RefactorHub is available on GitHub. You can use it, fork it, and extend it. Thank you.
Hello, everyone. Welcome to the session on source code analysis. My name is Gemma Rodriguez from the University of Waterloo, and I will be chairing this session. Since I don't see any question, I will ask my own question to the author. So based on your study, have you identified in which cases the current refactoring tools give incorrect results?
Yes, and we found some edge cases that the existing refactoring tool failed to detect. Particularly, the refactoring were mixedly performed together with other changes, which hinder the evidence of such a refactoring. Yeah, but we also find that the existing catalog is also immature, that it is limited to handle refactoring instances in the wild. Yeah.
Okay, thank you very much. So if anyone has more questions, please join the discussion.